Hi, in this module, we're going to be talking about applying business analytics. We're going to work our way through several different use cases, and the idea is to link analytical business societal challenges with the appropriate methods of business analytics. But before we do that, let's start with some analytics humor. So one of the things that's always puzzled me ever since I was a grad student was keeping it straight in my head the difference between a type 1 error and a type 2 error, right? So a type 1 error is what we call a false positive. And recently I came across a nice tweet which has permanently resolved this problem for me. And so now whenever I think of a false positive, I actually see a picture of this doctor telling this guy that you're pregnant, right? And that's clearly a mistake. So that's a false positive. So you can keep that in your mind. And of course, on the right hand side, we have the countervailing sort of type of error out here, which is the false negative. Okay, so both of these are wrong. And speaking of false positives, I recently came across a very interesting challenge on Kaggle.com. So I encourage you to go out and check out Kaggle.com. This is an open innovation platform for data science, for analytics. And here, this is a challenge that it's actually a data science bowl, so it's a huge challenge. There's a lot of prize money associated with it. And it's related to former Vice President Joe Biden's cancer moonshot. And lung cancer is, the most common type of cancer. More than 225,000 cases were diagnosed in 2016 alone. Huge expenditure for our healthcare system, close to $12 billion estimated. And this is something that can be reduced and detected early. Okay. So if you do a low-dose CT scan, and these are typically used to see if the treatment is working, then you can go out and actually reduce a lot of these expenses and even morbidity that's out there. However, one of the big challenges that the current technology actually has a 95% false positive rate. Okay, so basically the CT scans, when they're examined, okay, the radiologist is not correctly able to determine whether it's actually working or not, right? So that is really so they can't detect whether the cancer treatments are working and if the tumors are shrinking over time, right? So 95% false positive rate, and the challenge is for people to go out and use machine learning algorithms to reduce this. Okay. Here is another example in the world of, I would say, textual mining or text analytics, where there are platforms such as Stack Exchange. These are essentially communities where people go out and pose interesting or issues that they have in doing analytics, right? So they may have a particular algorithm that they're trying to run in R or in Python, and they don't totally know how it works, or they may have a problem to estimate a causal effect. In this case, maybe there are other, scientific questions, physics questions. So they go to these communities and, type in free text, and the community organizers like to take this corpus of text and tag them so that, in the future, people can find things more easily, right? So this is just basically the problem of organizing free text by tags. And as humans, we can do it, but if you get a new question, wouldn't it be nice if a machine could automatically generate a nice tag for it, right? So this is another challenge that's going on Kaggle. Basically, in this competition, they provide titles, text, and tags of Stack Exchange questions from 6 different sites. And then the task is to tag predictions from unseen physics questions, right? And you want to solve this via a standard machine learning approach that will use a training set of data that's already out there with questions and tags, and then apply that to new tags that come in. Okay. Here is another interesting example of big data, machine learning, and conversation. So I'm just going to play the video here.
These guys are working, miles and miles away from shore. They're out on the open ocean, and it's really hard to understand what's happening on board the boat, and particularly if they're getting bycatch, if they're catching turtles or sharks. And so one way to solve that problem is to put a human observer on board the vessel. Looking into the future, one approach would be to use cameras instead, and that's great because it's a scalable solution. Cameras are a one-time cost. It's relatively easy to install them on a boat. There's not a bunch of logistical problems. But what you run into there is that you have a ton of information. You have a ton of data flowing off that boat in terms of pictures or video that the cameras are taking. So the Nature Conservancy is interested in applying machine learning and artificial intelligence to the video review process. And the way to do that is to run a challenge. We'll put up a certain amount of money, a prize purse, and ask data scientists to look at all of this video and derive algorithms or produce algorithms that can predict with a high amount of accuracy when fish are being caught and what types of fish are being caught. The Nature Conservancy sees itself as an early investor in technologies that have the potential to have a big impact on conservation. We're providing the incentive for other actors, smart people that understand machine learning, to apply their skills to this industry where they may not have that incentive otherwise. In 5 years, you could imagine that we have a majority of the fishing vessels out there using camera systems because the technology is so cheap and the review process is so efficient. With the data that we're getting on this project, it creates some level of accountability in the fishing fleets and gives consumers assurances that the fish that they're eating has been caught sustainably.
So you see this really interesting application here of using image recognition to look at the type of fish that are coming in this video feed, that are being caught and captured in this video feed, and then determining whether this is kind of kosher or not. Okay, other examples here are a few business contests that I've interesting ones that I've seen on Kaggle in the past. This is by Prudential Life Insurance Assessment. And basically, you can see out here that they actually provide the students or the contestants with 3 data sets. This basically is a training data, right? It's pretty large. You can see 2.42 MB. And in this data set, you're provided over 100 variables describing attributes of life insurance applicants. And the task is to predict the response variable for each ID in the test set. So this is the training set, this is the test set, and response is an ordinal measure of risk that has 8 levels, right? So high risk to low risk at 8 levels. You have 100 different attributes. Can you train a predictive algorithm to go out and do that, right? So really, really interesting and easy to comprehend application of prediction in this case for an insurance company, right? Prudential. Here is another one actually from the insurance industry. This is a marketing application. So here, essentially, there's another company called Homeside Home Insurance. And the idea is that using an anonymized database of information on customer and sales activity, including property and coverage information, Homesite is challenging you to predict which customers will purchase a given quote, right? So they have data from the past where they have made certain types of offers, certain types of quotes given to customers. Some have purchased, some have not. That's a training data set. Can we, again, go out and actually derive an algorithm? Can we derive a rule to learn from that and predict whether a new customer is going to purchase a quote or not? Okay, so very classical examples of prediction. Okay, here is another example project that we were involved in where a large retailer invested in developing a mobile app, right? And as many people who downloaded the app and used it, that many people also ended up actually churning from the app, right? So churn prediction, is a very classical canonical case of predictive analytics. And here you would use all kinds of data that you know about these customers, including what they do on the app. If you have data about their physical transactions, which stores they visit, other lifetime marketing metrics like recency, frequency, and monetary value of purchases, we can throw all of those into again the kind of different. We can try them in terms of predictive accuracy using several different machine learning algorithms. Here is another example of, in this case, actually a hair salon, a nationwide hair salon, thinking about how to determine the right product mix for the right stores in the different geographies all across the country, right? So very simple example of unsupervised machine learning, of clustering, of transaction data, right? So if you look at, just go and see what is actually selling in these stores, then what you can do is, if you have maybe 2,000 stores nationwide, maybe you can cluster, those stores based on the product mix that they sell, and come up with 3 or 4 or maybe 5 different segments of actual products that you can then go out and procure and ship differently, right? The current process in this company, or the past process in this company, was actually just doing this by brand. So every location in the same brand got the same product mix, irrespective of actually what people were buying and what were the underlying demographics of the people out there. Indian people like me have different hair than maybe Hispanic people, and they may have different hair from other types of demographics. So naturally, the idea is that maybe we can let the data speak. We can look at the transaction data. We can see what items are sold over a certain time span. Take that data and you don't want to have 2,000 different product mix plans, right? That would drive your purchasing people crazy. But how about maybe 6 or 7 of them, right? And that's a very good example of application of clustering. Here is another example of taking clustering and unsupervised machine learning and applying it to customer data, right? So Sun Country, local Minneapolis-based carrier, essentially wanted to understand their customers better, right? And they have, again, transaction level data for every person, every flight who's flown. You can start, creating interesting features out of this data set, and then, understand whether their loyal customers are somewhat different in terms of how they fly, how frequently they fly, where they fly, how much they spend versus maybe the non-loyal customers, right? And this then, of course, turns out to be interesting from both a product design and a marketing perspective. Here's another interesting application